base a of x. Y equals log base a of x. Y equals log base a of x. That's how you say that out loud. The way I remember the conversion, this is log form. What's the other one form called, do you think? Exponent form. That's a good guess, though. Those are both great guesses. The way you remember how to convert it, it's a little circle. A to the y equals x. Remember that circle. Whatever the base is, a to the y equals x. Are these always going to be the same letters? No. Are they always going to be the same numbers? No. But is it always going to be this relationship? Yes. The definition of a logarithm is that this is the same thing as this. This is the same thing as this. Why do we use them? It seems like it's pointless. We're just rearranging a bunch of stuff. Anybody know why we use logarithms?
Oh, well, that wasn't my question.
Oh, what's your question?
I was just...
These two things. 3 squared equals 9 is the same thing as log base 3 of 9 equals 2. Because 3 squared is what? 9. Remember that circle I showed you? The base to what it equals 9. Side note, is there anything in front of the logarithms right now? Notice how there's no number? What's the invisible number right here? 1. There's a 1. So all of what we're doing right now is with a 1. Remember how when we first started factoring, what was the nice number we liked at first? 1. Will we put other numbers out there? Yes. Yeah, but we'll have to take care of them first. But I wanted you to make sure you do it with all these 1s. Oh, look, this looks terrible. Like 1/5 to the -2 is 25. That's true. How do you write it in logarithmic form? Log base, what's the base here? 1/5. So what's the base here? 1/5. So it's 1/5 to the -2 is 25. These are the same statements. Left column is exponential form, right column is log form. That's in log form. So this is log form. One way to attack log form questions is to convert them to exponent form. Can someone tell me what the exponent form is going to be on this one? Someone raise their hand. Gabby Recker, tell me what the exponent form is going to be.
4 to the -2 equals x.
4 to the -2 is x, because it's 4 to the -2 is equal to x. What does 4 to the -2 mean? 1 over 4 squared. So what does x equal? 1 over 16. Exactly. We just solved our first log equation. Are there any questions about what we just did right there? What about this one? Oh, it looks so terrible. Oh my God, Mr. Seamon, there's fractions in it. What am I going to do? What form is this in? Tell me what it is in exponent form.
So,
Say.
1/2 over to the power 2.
Yes, exactly. And now, is this just an equation we can now solve?
Yeah.
Yeah. What is 1/2 squared?
1/4.
Oh, yay. So we have 3x is equal to -3/4. We divide both sides by 3 and we end up with what? X is equal to what? If we divide both sides by 3, what do we end up with? -3 over 12. So it's -1/4. Done. So one method you have for solving log equations is to convert them to, is that the only way we're going to have? No, but it is one way? Yes. Try doing this one by yourself right here. How it works here. So you have x squared is equal to what? What does x squared equal? 3. So x is equal to plus or minus the square root of? But, so that's two answers. X is equal to √3 or x is equal to? Ah, but what did that definition tell you? X has to be what? Greater than 0. So it's not that one. So x is definitely equal to √3. Exactly. So one way to solve log equations is to convert them to exponent form. Here's some other properties.
But that says x.
Yeah?
X cannot be... Oh.
In the definition it says positive. See? Yes, what's up, Gabby? Log base of what? 2 times 2 times 2, right? What did I say you could do with multiplication on the inside? That's the same thing as addition on the... So this is log base 5 of 2 plus log base 5 of 2 plus what? Do we have the same thing 3 times?
Yeah.
What's an apple plus an apple plus an apple?
3 apples.
Ah, so we have 3 times log base 5 of 2. Let's go over here. What does log base 2 of 7 to the 4th mean? Log base 2 of
7 times 7 times 7 times 7.
7 times 7 times 7 times 7. Oh, that's log base 2 of 7 plus the same thing, right? So how many of these apples do we have?
4 log base 2 of
Okay, log base 2 of 7. Can someone tell me what the rule is? What can I do with the exponent? I'll give you a hint.
Move it to the
Move it to the what? Coefficient, exactly. And can you go backwards with that too? Where did that 3 end up? Oh, right there. Where did the 4 end up? Right there. So what does that mean the rule is? This. What can you do with R? Bring it to the... And you can go either direction with this. You can go either direction with this.
That's only when the coefficient is 1, right?
If the coefficient has to be 1 on the left side. Yes, exactly. This takes the whole thing. Absolutely.
So when we answer those, that's going to be the answer.
It's good. Well, it's not going to be the answer. It's just it's going to be part of the work you do. Remember how I said at each individual step, there's only like 6 things you could do. Here's one more. So what could you do with this 2 right here?
You could break it down into 4.
You could bring it to 2 times log base 5 of 4. That sometimes bringing the exponents to the front is huge. This leads me to my second reason why logarithms are important. What's one way to write really big numbers? Using exponents, like 2 to the 70th power. Is that a huge number? Yeah, working with really big numbers can be hard, but when you use logarithms, is it a lot easier? Yeah. So what can you do with this one? Where can you bring the 5?
Down to the front.
To the front. Exactly. You can bring it to the front. So what about this one right here? That's a separate one. What power is square root?
1/2.
So that's log base 7 to the what power? Where can I bring that 1/2? So this is the same thing as 1/2 log base b of 7. Same thing. All we're doing is rearranging. What about this one right here? What does this mean right here? What power?
1/5.
Exactly. So that's x squared to the what power? What do you do with powers of powers? So that's log base 2 of x to the what power?
2 over 5.
And what can you do with 2 over 5?
Move it, so 2 over 5 log base 2x.
Exactly. Now we haven't solved anything, but have we rearranged them?
Yes.
And it makes it a lot easier because is that x all alone now? Yeah, we've done a lot of work in algebra isolating x's. And you're going to do more of it. What could you be asked? You could be asked something like, well, here's everything we've learned so far. Really careful. There's no division.
Would you do 4 equals x to the 3 to the 4?
Close, you're making it harder than it is. This one's hard. This is a trap. Yes, Chris, what do I do?
Log base 4
Of
4
plus
plus 3
log base
log base
4 of
x of
x to the third. Yeah.
Can't you bring the...
We will. Do it step by step first.
Yeah, okay.
What is 4x to the third? That is 4 times x to the third. So these are the two things. You have to recognize that is 3 touching this 4? No. So that 4 is there, and this x to the third is there. What is log base 4 of 4? What is log base 4 of 4? 1. Remember that? Log base b of b is always what? 1. So this is 1. Oh, what can I do with this? What's the only thing I can do? Now I can bring down the 3. Log base what?
4.
You have to say base 4 of x. This is as far as we can go. There's nothing else to do. The key thing, the reason this was a trap, is that 3 touching that 4. No. So can you bring that 3 to the front? No. You will do that, but that's technically making up a rule. You can't do that. Try this one for me. Simplify that as far. True, but what's around the division? You have to get rid of that first. What do you do? Sorry, Sarah. Yep. You could square root everything, but what power is square root?
1/2.
To the what power? What can I do with that 1/2 now? So it's 1/2 log of m over n. So now, Gabby, you're right. Now it is.
What about the 7?
Oh, log base 7. Sorry, log base 7. Yep. Now what can I do? Yes.
1/2 log base 7
Of.
m plus
Close.
minus
1
log
base
n.
7 of
7 of
n. Yes. There it is right there, everybody. Look.
5
Log base 5 of.
base 5 of BC.
So now what? Someone, hold on. Next person. What do I do next? Gabby, yeah.
Move the
Yep, 2 log base 5 of a. And what does the next thing turn into? What can you do with this right here? Someone tell me what I can do with that. Verdi.
You have addition, so log base 5 of B
Mm-hmm.
plus log base 5 of C.
You see how I put parentheses around the whole thing? Because this is the same thing as this. So that minus sign is here, but this is the same as this. You can leave it like this, but if you went any further, what would you have to do with this negative sign? Distribute it in. It would be 2 minuses. You have to be very careful. Very careful. Yes?
You have to split up the B and the C.
To finish this problem, yes. That's what I want. If I asked you to expand this as far as possible, this would be the full expansion. So you might ask yourself, what's the point? Because this right here, it seems like this right here, it seems like that is more complicated than what we started with, right? It's like more stuff. Here's the thing. Big, complex statements are a lot easier to do when you have lots of easy, small pieces. So the first method we have for solving log equations was take it from log form and put it in exponent form. Another method is going to be take this big nasty log and then break it into little pieces and do each little piece. The little pieces are going to be a lot easier. Let me see if I pasted the next set in here. So multiplication means addition. So we have log base 10 of 7 plus log base 10 of 8. Can someone tell me what 2 is? Do you guys agree? Yeah. Log base 10 of 7 minus log base 10 of 8. What do you do with 4? What do you do first with 4? What do you do? Yeah. The 6. What do you do with it? So 6 log base 10 of. Can you do anything with that? No. 3 is not a nice power of 3. 10 to some power does equal 3, but it's not a nice number. What about this one? What do you do with the 9? So this is log base 3 of 3, but what is log base 3 of 3? So that's 9 times 1, so what is it? So this answer is just 9, actually. Okay, so this one's a little tougher, though. Let's talk about 3, kids. 3 log base 3 of 4 equals something. We don't know what it equals, and this is, you can figure this out, you don't know what it equals. Give me a letter. What's your favorite letter, Gabby?
G.
G. Let's say G. I'm going to say G is equal to log base 3 of 4, okay? I'm just going to say G. So this means 3 to the G is equal to question mark. Are you okay so far?
Yeah.
I just assigned it a letter. We've done things like this before. If I just gave you this right here, what form is this in? What form is that? That's exponential form. So what's that first thing I taught you about how you can solve some exponentials? You could convert this to log form. What is this in log form? Can someone tell me what that is in log form? Log base 3 of no question mark is equal to what? Do you see this? Log, because remember the circle. 3 to the G equals, oh, is that what it is?
Yeah.
This is the same as this. This is the definition of logarithm. This is the same as this. But what did G equal? Log base 3 of question mark is equal to log base 3 of 4, right? Oh, wait a minute. Let's look at this. So what does question mark equal?
4.
Let's go back up here. Here's the key thing. See this right there? What's that special rule? A to the log base A of x is always equal to what?
X.
Is always equal to x.
Cool.
So 7 to the log base 2 of 9. What does that equal to? 9. Pi to the log base pi of, oh, sorry, log base, this is supposed to be 7 right there, sorry. Log base pi of 12. What does that equal? 12. Exactly. So this is the special rule. A table to the log base a table of a pony is equal to pony. But what's the key thing that has to be the same in each of these? The bases have to be the same. You see the bases are the same? The base of the exponent and the base of the logarithm. Exactly. So what do you have here? You have, what do you have? Log base 7 of the cube root of 13 minus log base 7 of PQ squared, right? You're subtracting that whole thing. So that's going to be 1/3 log base 7 of 13 minus this thing, which is log base 7 of P minus 2 log plus, yes, plus, sorry, log base 7 of q. Why did I put the 2 in front?
Because 2 squared.
Yeah. So you could distribute the negative sign. If you stop there, that's fine. You could, or you could stop there. What about this one? Log base 2 of cube root of x plus log base 2 of the 5th root of minus 2 log. I'm just going to do that one. Is that correct?
No.
But am I done?
No.
Powers, so 1/3 log base 2 of x plus, yeah, log base 2 of y minus 2 log base 2 of r. And again, it looks worse, but this will make your life so much easier when we do the equations. We're learning how to manipulate them right now. We're not solving these yet. We're log base 10 of,
x plus 3 x minus.
yes, nice. What do you do with this 3 here? Hey. What do you do with the 1/2? Hey. So what do you have here? Log base p of x to the, and this is plus log base p of the square root of, why square root?
Because 1/2.
Mm-hmm. And this is minus log base p of z to the 3/2 minus log base p of a to the 3rd
Wait, can you do z
to the negative 3.
square root of z?
Oh yeah, we can rewrite it. Yes, yes. So you could write this as log x to the 3rd plus log
Px.
p, thank you, the square root of y minus log base p of, what is this? The square root of z cubed minus, sure, you could do that. So now when you do this, read it from left to right. So what does plus mean? So this is log base p of x cubed square root of y, right? What does this minus sign mean? So then where do you put that?
You put that
Underneath it, and then you plug this in underneath it. So you have to be really careful at this point. Here's what you could do if it really helps you. Do you see both of these negative signs? What could you factor out of both of them? You could factor out negative and make it negative of log base p of the square root of z cubed plus log base p of, like this, right? What does this mean? What does plus mean? So this is minus log base p of the square root of z cubed a to the 3rd. But what does minus mean? Divide. So you have log, and it duplicated, sorry. This is log base p of, what goes on top? X cubed square root of y over square root of z cubed. I just put the a out front. This is what the final answer would be. You guys are really close here because when you have to be really, really careful here. When you did this one, Chris, you just ignored that negative sign and did those two. You have to be very careful to do this, factor it out and then do it. Be very careful. That would have earned like 9 out of 10 points there. Most of that is really, really good. Most of that is really, really good. So what have we done so far? We've expanded and we have compressed. Have we solved any of these yet? No.